Hello, and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 22. So question number 22 says, using the fact that the log of 3 base 4 is approximately 0.8 and the log of 5 base 4 is approximately 1.2, estimate each of the following. Okay, so 22a. We want to estimate the log of 3 halves, also 1.5, but we want to think of it as 3 halves, base 4. So this question is definitely not asking you to just go directly to your calculator and just type in, log of 3 halves base 4. It says using these two approximations, as well as sort of like what else we happen to know about logarithms, right? Try to get these estimations specifically without using a calculator, right? Just using like the properties of logarithms. So what we have here is we have essentially we have the log of a quotient, right? So if you take a look at what's being fed into the logarithm here, we have the log of 3 divided by 2, right? Now again, that does equal, just a number of like 1.5 or 3 halves, but ultimately at the end of the day, 3 halves is a quotient, which means we can use the quotient rule for logarithms to sort of expand this out a little bit. So the quotient rule for logarithms says that if you have the log of a quotient, then that is equal to the difference, right? So subtraction, the difference of the log of the numerator and the log of the denominator. So using the quotient rule, I can break this up into the log base 4 of 3, and then minus, and again, that minus comes from the fact that we're dividing, and so the quotient rule says that we want to subtract the log, base 4, of the denominator, which is 2. All right. So notice that we now have the log of 3 base 4, which we're told is approximately 0.8. So we're going to use what they tell us, right, that this quantity, log of 3 base 4, that is approximately 0.8 minus. Now, they don't tell us the log of 2 base 4, right? They tell us the log of 3 base 4, they tell us the log of 5 base 4, but they don't tell us the log of 2 base 4. So we're going to have to sort of figure this out. Well, I'll do this over here as a kind of a sidebar here. Let's say that we have the log of 2 base 4, right? And we're trying to figure out what that is, right? So let's just call that x for a second, right? So we're trying to figure out what does x equal, and if we're able to figure that out, then that's what, log of 2 base 4 is. So notice that if I take this logarithmic form, and if I convert it into exponential form, what I end up getting is my base is 4. The exponent is the result of the logarithm, so that's going to go right there. That's x. And then this is going to equal what's being fed into the logarithm, which is 2. All right, so these are mathematically equivalent statements here. So notice that what this is saying is it's saying that, well, x, which is ultimately what I'm trying to find here, x is it's the exponent on 4 that results in a 2. Okay, so that's sort of our task right now, is to figure out, well, what is the exponent that I would want to put on 4 in order to get a 2? Well, I think we all know that the square root of 4 is 2, right? And square roots can be written as fractional exponents. So if I want the square root of something, I can raise it to the 1/2 power. So when I see this, when I see 4 to the x equals 2, and the question is, all right, well, what is the exponent that I need to apply to 4 to get 2? Well, I know that if we raise that to the 1/2 power, that's equivalent to just the square root of 4, which results in a 2. So getting back to the original problem here, if you're not there already, all right, try to recognize that ultimately logarithms are exponents, right? And you're kind of answering the question of what is the exponent that I want to raise this to? Oops, didn't mean to erase it. 4. What is the exponent that I want to raise my base to that's going to result in a 2? Okay. And so the answer to that is 1/2, right? Because the square root of 4, which can be rewritten as 4 to the 1/2, the square root of 4 is 2. So my answer for the log of 2 base 4 is 1/2. And just because I'm already dealing with decimals, I'll just convert that 1/2 to a decimal, which is 0.5. So even though we're not told the log of 2 base 4, we are sort of expected to be able to figure it out because it works out quite nicely. You are not expected to know that the log of 3 base 4 is approximately 0.8. I certainly didn't know that, right? That's why they tell us that, right? But we can figure out the log of 2 base 4 just based on what we know about logarithms and what we know about exponents. All right, so this is 0.8 minus 0.5, so we get 0.3. And that's my answer for A. All right, B. For B, we want the log base 4 of the square root of 20. All right. So I'm actually noticing that we could simplify the square root, but I'm actually not going to go that route. I'm sure if you simplify the square root, that would still get you closer to answering this question at some point. The problem is, even if you simplify the square root, you're still going to have a square root because 20 is not a square number. So instead of just kind of futzing around with the square root, instead I'm going to use I'm basically going to set up this question so that we can apply the power rule for logarithms. Before I do that, I want to rewrite my expression here. So it's log base 4. And what I want to do is I want to rewrite, so this is the square root of 20. I want to rewrite that as 20 to the 1/2 power. So this is kind of like a little trick that we've now seen several times. We just saw this in A. But a little trick that we can treat roots as fractional exponents, and specifically a square root is something raised to the 1/2 power. And like I alluded to, the reason why I'm doing this is because I want to apply the power rule. The power rule for logarithms say that when I have an exponent on my argument going into the logarithm, what I can do is I can take this exponent, whatever it is, and I can put it out in front like a coefficient. So sort of take it out of being an exponent and instead treat it like a coefficient. So that 1/2 is going to come down, and then that's going to get multiplied to the logarithm of, now it's just 20. It's no longer root 20. It's just 20 base 4. Okay, so I'll keep my 1/2 there for now. So I've got the log of 20, and I certainly don't know what that is off the top of my head, right? It's what exponent do I want to raise 4 to get 20? All right, well, I know that 4 squared is 16, and I know that 4 cubed is 64, so it's like a little bit more than 2. But beyond that, I don't really know what it is. I know that they told us the log of 3 base 4, and they told us the log of 5 base 4. Well, if you think about the the different properties of logarithms, or the rules of logarithms that we've seen now a couple times here, we've talked about the power rule, all right, and we applied that in this problem, all right, but there's no real, I can't really apply the power rule again to get any closer here. I don't really see any kind of quotient that kind of jumps out at me. So really, I think our only option left, if we're going to use any kind of properties of logarithms, is the product rule, right? And as a reminder, the product rule says that the log of a product is equal to the sum of the logs of the individual factors of that product. The reason why that's helpful is because we have a product here in the form of 20, right? 20 can be expressed as a product. And specifically, it can be expressed as the product of 5 times 4. Now, obviously, there's other ways of writing 20, right? There's 20 times 1, but that doesn't really help us because then we still have log of 20, and that's kind of what we're trying to break apart here. You can also write 20 as 10 times 2, and we could figure out the log of 2 base 4. We just did that in part A. But then we've got log of 10, and that doesn't really, we'd have to break that up. And so, I don't really see that as being sort of the best way to go about this. But if we write our 20 as 5 times 4, well, notice that we know something about log of 5 base 4, so that's good. And then we're going to have log of 4 base 4, which we'll talk about in just a second. So we've got 1/2. Now, notice that the 1/2 is being multiplied to the entire logarithm, right? It's the log of 20, which is the log of 5 times 4. If I'm going to apply the product rule, what's going to end up happening is I'm going to end up getting 2 logarithms, okay? But the 1/2 is being multiplied to the original logarithm, which means as soon as I break this up, I'm going to need to introduce a set of parentheses right there, because that 1/2 is being applied to both of the upcoming individual logarithms, because it was being applied to the entire original logarithm. So if I don't include parentheses, that would be incorrect because it's not being applied to the entire thing. So I'm going to break up my logarithm using the product rule. So this is going to end up being the log of 5 base 4, and then plus, right, because it's the sum of the log of the other factor, which was 4 base 4, right? And again, you can see that if I don't include parentheses, okay, if I get rid of them and if I just say times, well, that 1/2 is currently not being multiplied to the log of 4 base 4, right? And that's wrong, right? Because this 1/2 is being applied to the entire thing. So just because I break it up doesn't mean that all of a sudden it doesn't get applied to the log of 4 base 4. So get rid of all my extra arrows here, and I'm going to reintroduce the parentheses that we have to include. Otherwise, our answer is incorrect. All right, 1/2 drops down. So now we have the log of 5 base 4, and we're told what that is. We're told that the log of 5 base 4 is approximately 1.2. Okay, plus. So now we have the log of 4 base 4. So again, this could either be something that you just straight up memorize, or if you don't like memorizing things, you just got to remember what a logarithm is and what it's saying. So if you don't know what this is, again, you can think of a logarithm as being an exponent. So if I let this thing equal x, I'm trying to figure out what x is. Again, if you convert this to exponential form, I'm going to take my base, which is this 4, right? So that 4 goes right there. And then x becomes the exponent. And then the result of raising 4 to the exponent is this 4. So this 4 goes there, okay? So ultimately the question becomes, what is the exponent that I want to raise 4 to get 4? All right, well, if that sounds like a silly question, it's because it is, because 4 to the, get over here, 4 to the first equals 4. right? That's the power that you raise 4 to get 4. So ultimately what this is saying, and this is a good thing to remember, is that if you have the log of a base a, well, that will always equal 1. Because pretty much by definition, if you want to take a and raise it to some power and get a, well, you don't want to change it. You just want to get a again. So you raise it to the first power, which does not change your quantity. So for any a, the log of a base a is 1. So the log of 4 base 4, they don't tell us that, but the expectation is that you would know that the log of 4 base 4, just like the log of anything base itself, right, is going to equal 1. All right, so we have half of 1.2 plus 1 is 2.2, and half of that is 1.1. And that's going to be my answer there for part B. So between A and B, right, a good question to check and see, do you understand logarithms? Do you understand sort of like how we can use them, how to use the properties? So just as a reminder, for A, we needed to use the quotient rule. Then we needed to use our approximation, and then we did need to know this. We needed to know that the log of 2 base 4 is 0.5 because it's 4 to the 1/2 equals 2 because the square root of 4 is 2. Okay. So there was some sort of outside knowledge that we needed here. And same thing with B. We applied the power rule to get rid of the root. We then used the product rule to break up our product. We rewrote 20 as 5 times 4. We used our approximation for log of 5 base 4, but then we did need to know that the log of 4 base 4 equals 1 because 4 to the 4 is first power, or 4 to the first power is 4. So again, using some good properties of logarithms, and then also just sort of like what a logarithm is in order to approximate each of these values. And that's question 22.